Today, we would discuss with you the concept of cloud computing and the concept of clouds as one of the main methods to provide computing resources today that is used almost by every web service that you would find in the internet today. So, the clouds. Let's discuss first where did the clouds come from and why do we call this method to provide us resources to the communication, computation and storage resources, why we call it cloud. So the cloud symbol, as you can see it here in this diagram, it was quite common and it was traditionally used to refer a complex cloud infrastructure whose internal structure is not important from the endpoint of the user. When we have some computing resources, when we have some infrastructure that our user is connected to, but it is an internal structure for us, it is like a black box. But this black box is located somewhere out there in the clouds. We can draw it like the cloud network infrastructure. So the term cloud computing became fashionable at the end of 2007 and early 2008 after the IBM and Google started their cloud computing initiative for the universities in the United States. As you can see here from the citation from the New York Times magazine, Google CEO recalled that they had a meeting with the CEO of IBM, and on this meeting, they sketched out their vision of cloud computing on a whiteboard. It was in December 2006, and after they sketched their vision, they tried to emphasize and urge IBM chief to cooperate to build the skills that are needed to manage such big computational infrastructures. Before the term cloud started to rule the world, there was another approach to this concept, and the term greed was used before to show that there is some very huge and distributed computing system that is beyond some interface. But the term greed, it was changed last 10 years, and right now it only provides a definition for high scalability scientific calculations, but not commercial projects that provide big computing resources. But this term, the term cloud, it was built not from the sketch. It was not defined in 2006 by itself. There was previously some terms that define the similar concepts. As I told you previously, it was the term greed that was defined as a set of independent computers that can provide you computational capabilities in the way like right now we are getting the capabilities of power grid when we're connecting our computers and vacuum cleaners to the outlets in the wall so they can get the power to work. So the term grid was provided like this. But even before this, there was one term that was the main father or even grandfather of all these concepts. This term was utility computing. And the utility computing is provision of data and processor capacity that is organized according to the principles of utility services on the basis of pay-as-you-go principle. That term is very old, and you can see here that this term was defined in the paper, Utility Computing, a superior alternative, on the conference that was provided in 1974. So in the era of the first computers, even personal computers was not a concept in 1974. It was just very beginning of small computers, or microcomputers as they call them. In 1974 already people thought about this concept. How can we organize the provision of computational resources as a utility? So like you're paying for the gas, you're paying for the electricity, you're paying for the water. So let's provide you these capacities of computational power, so you would be able to pay us as you use this computational power. And if you do not need, you would not pay any money for us if you did not use this power previously. But as you know, this concept was not truly won the minds of the developers and the server providers till the beginning of 2007, 2008. It was due to several things. First and foremost, the concept was not working without huge computing powers and without reliable distributed methods to manage virtual machines. As the server virtualization concept started to emerge, the cloud computing became more and more popular, and it became possible to automate the provision of computational power. We would discuss the basics of virtualization and what was in the foundation of cloud computing on our next lecture. Today we would discuss the concept by its own. What is cloud computing? So cloud computing, if we're using the definition of the National Institutes of Standard and Technology, it is a model for provisioning of on-demand, seamless network access to a common pool of abstract, virtualized, dynamically scalable computing resources, such as networks, servers, storage, applications, and services. These resources are dynamically scalable to adjust to the current load, ensuring optimal utilization, and are usually provided on the pay-as-you-go basis. So let's go through this definition. First of all, cloud computing is a model for providing on-demand network access. That means that if you do not need some computers, if you do not need some power, and you do not demand it, then the cloud computing would not provide you this power. That is different from the concepts that there was before. So you need first to buy the server. Previously, to cloud computing, if you wanted to establish a good web service, you need to buy your hardware, bring it to the server provider, capacity provider, and install this server in their racks. So this is not on demand. This access is provided only for you and only because you installed this hardware. Seamless network access. That means that where it is not you can access these resources from any point in the world. Seamless network access to a common pool of abstract, virtualized, dynamically scalable computing resources. So what is this? What is the common pool of abstract, virtualized, dynamically scalable computing resources? So this abstract pool means that in reality, the cloud computing provider have a lot of similar servers, but they do not provide you the direct access to this pool of servers. This is a pool of servers, but they do not provide you the direct access to this pool of servers. They are abstract and virtualized. That means that this server by itself have his virtual machines installed on this server, and these virtual machines are provided to the end users. And each of these servers can be divided into the set of virtual machines. And these virtual machines and these resources are dynamically scalable. So if you want one virtual machine, you can get it and you can work with it. If you want two virtual machines, you just ask, give me two of these. If you want bigger virtual machine, you can close these two virtual machines in some time and ask for bigger virtual machine, and it would also be provided to you. And if next day you want not 10 virtual machines, but 100 virtual machines, it would also be provided to you, so you can deal with the huge overload of the requests that you are going through right now. So these resources are dynamically scalable to adjust the current load, ensuring the optimal utilization, and are usually provided on the pay-as-you-go model. So there is a common tale about one of the first actors in the world who started to provide virtual machines. And this actor, you know, it is Amazon. Amazon. So please tell me in the chat, what is the Amazon today, and what was the Amazon, let's say, in 2005? So Amazon in 2005, what was it? Online store, that's right. The Amazon was online store, online shop. That's right. So, who can imagine why online shop would try to go and to become the cloud computing provider, the biggest cloud computing provider in the world? So, to become big cloud computing provider, you need a lot of servers. And these servers should be idle for you. These servers would have, you should have these servers, but you should have not any load to work on these servers. So why Amazon would buy these servers and do not put anything on these servers? Why Amazon have additional servers in 2005, 2006, 2007? So they would be interested to sell these additional servers to you as cloud computing resources. That's right. Everyone can reach their servers everywhere. But why Amazon bought these servers first of all? Why did they need these servers? To reduce latency for their services, that is correct. But if you are working like an online shop, you know the amount of servers that you need to have the minimal latency. So why there are some additional servers in the on the Amazon that they do not use every day? So to understand this, you need to understand what is the pattern of the shopping in the United States. So I give you a hint. The shopping pattern in the United States, it is not trivial. It is not equally distributed through the year. So let's go here. This is the timeline of the year. And this is January. This is February. And this is October. This is November. And this is December. And here we would draw the relative amount of shopping, relative shopping amount. So if the distribution of shopping would be equal through the year, then Amazon do not need any additional computing capacity to provide the same level of latency. If the distribution would be like this, we know that we need like n servers to handle this distribution. And we know that if we have n servers in our site, we would handle all the requests through the year. But it is something different. Think about what is the time of the year when you do most of the shopping. In the Western countries, okay? Western countries, the same is in Russia, the same is in Europe, the same is in United States. We have very, very definitive pattern about the amount of shopping in the year. The year starts very, very low because in January no one wants to buy anything. In February we're going a little bit more, then we are going to the relative part in the middle of the year. And what is in the end of the year? What are the main cause of this rush in the end of the year? What do we have there? What is the winter season? What celebrations do we have in the winter season? We starting from the Black Friday, that's right. Black Friday, then we have some different celebrations. We have New Year, we have Christmas, and we have a lot of other celebrations in the end of the year. So the amount of shopping is going way up in the end of the year. Christmas, that's right. Preparing to these holidays means that a lot of people want to buy a lot of stuff. And the analysis show that this part of the season, from the end of October to the end of December, it provides 2/3 one half or two-thirds of the yearly income for the online shopping company. And what do we have here? If we need n servers to work with this amount of requests, then when we go in here, we need 3n servers to work with this request. So we have the capacity to process the peak requests, that is 3n servers. And these 3n servers, we need them only 3 months a year. That is 1/4 of the year. These 2n servers would be idle. We don't need them. We don't need the capacity of all these servers. So as a shopping company, what can we do? We can sell them, but it would be very cheap because it would be second-hand servers. The other way, we can provide them for a rent. We can provide them to other users who may need them. So let the users rent these servers. But the Amazon company, they decided to go further. They would not rent you a server. They would rent you a virtual machine on the server. Or they would rent you the capacity on their storage device, so you can go and save something there. So they decided, okay, we don't need all these n servers through the year. We would be able to use them in the peak for the shopping, but when they are not needed, we would be able to rent these servers to other users, and these other users would pay us money to use these servers. So this change of the approach to the services you saw when we discussed the letter from the Jeff Bezos to the developers of the Amazon. And that was the core about how would they deal with these servers through the year when these servers are not needed by the Amazon itself, and then when they can rent them to other users. So let's discuss these features of the cloud and what distinguishes cloud from the other methods to develop and to provide resources. First of all, it is self-service on demand. So that means that user can allocate the required amount of resources to themselves. You do not need to go anywhere to shake hands with the administrators of some server site. You just go to the web page, or you go to the API, you send the request, or you push the button and you tell, I need 10 new virtual machines right now. Self-service on demand. You are the person who decides how many resources you need right now, and you demand them and you get them. The amount of resources of public clouds today, virtually infinite. Of course, if you are a new user, you would not be able easily access thousands of virtual machines because they have some limits to these newcomers. But if you are a big business, it is very simple. You can ask 1,000 machines right now or 10,000 machines tomorrow. Second, widespread network access. Cloud platform resources are available through the standard network mechanisms, and you use standard HTTP protocols and HTTP-based protocols, TCP/IP based methods of interaction with the resources of the cloud computing system. Third, resource pooling. Computing resources are combined to serve many different consumers. That means that if you have a lot of different resources, you can share these resources with different users. You do not provide your users specific access to a specific resource. You provide your users access to a pool of resource. Next, fast elasticity. Computing capabilities can be elastically provided and redistributed. If you need 10 computers today, or you need 100 computers in next 15 minutes, you can get your 100 computer units in 15 minutes. That is fast elasticity. And the amount of services provided is measurable. That is the core. The billing is the core of the cloud computing. When you use your cloud computing resources, the cloud computing provider would count every sneeze. They would count every byte that goes inside your machines. They would count every byte that goes outside of your machines. They would count every second of the usage of the virtual machines that they provided to you. They would count every API request that you invoked. Everything is countable, and everything you would pay in the end of the month. Pay as you go. What you used, you would be paid. You would be billed, and you would pay for this. So, if we would discuss the classification of the cloud computing, we would understand the models of the cloud computing services provision. And there are three main ways to discuss these services: on the level of flexibility, on the level of abstraction, on the level of ease of use, and what is the audience that these services are focused on. So on the top we have software as a service model. When we are discussing the software as a service model, we're discussing that our clients, our end users, can use the services that are provided by the cloud to solve their own needs. The biggest examples that we can figure out about what is software as a service, it is what we are using right now. YouTube provides us great capability to organize this lesson. And this lesson right now is organized on the cloud computing powers of the Google, because YouTube is a part of the Google company. I send all my data to the Google Cloud. They process this video stream data, and then they send you, the listeners of this lecture, this video stream with minimal delay. They also provide you great interface to communicate with me using this chat. They provide me great interface to organize this communication using the YouTube Studio. So this is approach software as a service. Other examples: Google Documents, email, online email accounts that you have, that you access through the web interface, for example, that is also software as a service. Dropbox, it is a great example of online storage where you send your data and they store this data for you. There is a huge amount of such examples to provide some software to the users that is provided to on the cloud capacities. So software as a service, it is for the end users. Platform as a service. This level of abstraction of cloud computing resources is focused on the developers of the applications, on software developers. On the platform as a service level, the cloud computing provider would provide you a set of services and API how to access these services. For example, when you create new application in the Visual Studio, and this application is a web service or a website, Visual Studio would ask you, would you like to publish it right now on my Microsoft Azure resources? Because Microsoft Azure is a cloud that is provided by the Microsoft Corporation. And you as a developer can say, yes, of course, I would like to publish this web application on your services. And you push the button and voila, and you have public name of the application. You can share this application with others. You just get the link and you share this link to the other users who can use your application from any part of the world. And you just build it from your computer using one button. That's a miracle. You don't know what virtual machines are in the Microsoft Azure basics to provide you these capacities. You don't know where they are located. You know nothing about this infrastructure. You just know that there is an API, there is your application, you push the button, and this application magically becomes a cloud application. That is platform as a service approach. And the most advanced approach and the most low-level approach that is available in the clouds, it is infrastructure as a service approach. The infrastructure as a service approach, this most focused on hardcore software systems developer when they want all the management took by themselves. They want to start from the scratch. When you work in the level of infrastructure as a service, the cloud computing provider provides you with the virtual machines. And this virtual machine, it is like a virtual server in the cloud. You can use it to fulfill all your needs. You can install web server there. You can install your database there. You can install your web service framework there. You can manually define how many machines you want. So this approach means that you have the most flexibility, but of course, it is not such an easy task to develop and to use as on the level of platform as a service, when all the necessary services are already provided to you by the web cloud provider. If we would discuss the same on the example of the food, then if we have on-prem server capacity, that means that you need to bring your own server and do with this server everything you want as you wish. The service provider would provide you electricity, and that's all. That is on-premise. Infrastructure as a service. You bought some meat, then you need to cook it, to serve it, and you would be able to enjoy it. Platform as a service. You bought some already cooked product, but you need to serve it on the plate, and you would need to provide it to your guests when they come to eat it. And on the level of the software as a service, you went to the restaurant with your friend and with your girlfriend or boyfriend, and you go there and everything is served for you. This is software as a service level. So here we see the picture about what do we have inside each of the service. Very high level of definition about what is going on. In this software as a service, you have applications. Platform as a service provide you services, and infrastructure as a service provide you the deepest level of abstraction that you can get in the in the cloud computing system. It is direct access to virtual machines. These virtual machines are based on the virtualization hypervisors that are installed on computational resources, networks, and local storage that the service provides in the cloud provider. Also, this is not the only way to distinguish between different clouds. The other way it is to understand possibilities of implementation models. Because not all clouds are public clouds, as I discussed before. Of course, we have some very well-known public clouds systems like Amazon Cloud, like Microsoft Azure, like Google Cloud. But there are different clouds that are installed inside the data centers of private companies. For example, in our university, we also have our private cloud, and some of you are using it. This is personal virtual computers. This is a private cloud that is provided to you as the users and as the students of our university. So private cloud can be deployed with a private data center to optimize the resources that are used. Because if we're using resources of a private data center without the virtualization, the efficient ratio of the resources is usually very low, about 5%. And if we provide the virtualization technology to this, so users can dynamically manage the load, the efficient ratio of the usage of these resources, it can be increased several times. So these are private clouds. Public clouds, these are data centers that provide resources to third parties over the internet. Google, Microsoft, Amazon, they are and IBM, of course, IBM is the fourth big player in the market. They provide resources to everyone who can pay them money. Hybrid clouds, they combine the possibilities and the features of public clouds and private clouds. When you have your private cloud installation, you can deal with this as your private cloud. You can process some data there. But for example, you have not enough capability to process some very big data. What would you do? It is possible to use public cloud capabilities to work with this problem. So hybrid clouds, it is a merge between private cloud and public cloud services. Cloud federations. Cloud federation means that we have servers of one public cloud, second public cloud, third public cloud, and they work magically together. Right now it is something like utopia because clouds do not have common API. Every cloud provider today would demand you to use their own API to access their capabilities, to access their services, to access their resources. Because these public cloud providers, they would like you to be as close to them as it is possible. So you can implement this separately for your own application using some common methods to deal with the diversity of public APIs. For example, you can use common containerization technologies, for example, Docker. So you can put your applications inside the Docker containers and manage them manually on each of the clouds. That is possibility. But you should implement this separately for your application, and that would be your own headache to deal with this stuff. So let's go next discussion about the advantages and disadvantages of cloud computing. So first, advantages of cloud computing. First advantage, it is you need no pre-investment in the infrastructure if you would like to create your own cloud computing service. Previously, before the cloud computing concept, if you wanted to build some web application, some web service, for example, YouTube, you need to buy all the servers you want to your users to access. And if you was wrong about the amount of users that you would be able to attract, then it is a huge problem. If you buy too many servers and you attract only very, very small amount of users, that means that you wasted your money. That means that your servers would idle. They would not provide any workload that would provide that you need. They would just stand by. You pay for a lot of hardware that you would not use. From the opposite side, if you would buy small amount of servers and you think, okay, I would my web application, for example, my online video streaming, would handle about 100 users per minute. Okay, that's great. And you start advertising your video streaming service and you have 1,000 users per minute. So now your very, very small server cannot handle these requests. And your server cannot handle requests. That means that your users, they are not satisfied. You have very, very small server. You have 100 users that can work, and you have 900 users who cannot access your server because it is in the idle state, because it cannot process your requests, because you invested too little in your infrastructure. And now these users, they say, you know what? I would not use your service because it is garbage, because it cannot handle my requests. I cannot use it, and they would go out to your competitors that invested in their infrastructure more, and they would go there. So that was before the cloud computing. Today, you doesn't need to make these decisions before. Today, you develop your streaming service and you go to the cloud computing provider and you say, okay, I need like 10 virtual machines to handle my requests for 100 users per minute. And they are working pretty good. And after you provide advertisement to your web service and you attract 900 more users, and they're eager to use your service. So what can you do in the cloud computing world? It is easy. You say to the cloud computing, okay, I have 10 virtual machines here. I need 90 more. I need 90 virtual machines here. And if you have a good architecture of your streaming service, you can easily scale the amount of machines. So all the users would be satisfied. These 100 users would have their own great response time, and these 900 users also would have their own great response time because you easily managed to scale your architecture. You managed to scale your basic infrastructure using the cloud computing capabilities. And after this initial flow of users would go down, and instead of 900 users per minute, you would have like 200 left. This is 2. Then you can tell your cloud computer provider, okay, I do not need these 90 machines anymore. I need 20. And now you would pay only for these 20 machines. You would pay for these 90 machines the time that you used, but from now on, your server, your streaming service would be able to handle 300 users per minute without any problems. Next, cloud service customers buy and use only the amount of information and only the amount of resources that they really need. As I said, you can order exact amount of virtual machines, exact amount of API services that you need to handle your amount of requests. You do not need to book it and to calculate what would be the amount before you start working. You would pay as you go. High scalability and flexibility. That is also an advantage because you would be able to scale your system virtually infinite amount of times. Good documentation, APIs, and sets of ready-made services. All cloud computing providers, especially public cloud computing providers, they would try to make you be as comfortable as it is possible on their services. They would like you to be in their infrastructure so comfortable, so you would be pleased to pay them all your money because they would take the headache of managing your servers to their site. You do not need to manage anything. They would deal with everything, providing you all the services you want for your money. And one more advantage is high geographical distribution and proximity to the end user. If you would take a look on any public cloud computing provider today, you would see that they have data centers all over the world. North America, South America, Europe, Asia, China, Australia, Japan. In every part of the world, they have several data centers. And if you would like to be as close to your consumers as you can do this using cloud computing providers. You can order these machines be in South America. These machines, they would be in Asia. So if you have customers in these parts of the world, these machines would be very close to them. Disadvantages of cloud computing. First, it is a lack of single universal cloud interface. Each application has to be customized for the specific cloud platform. As I said, from one side of the API, cloud computing provider would like you to be as comfortable as it is possible on their resources. On the other side, they want you to stay on their resources and do not use the resources of other providers. So they usually do not develop common APIs. They usually develop specific APIs that is suitable only for their platform. Second, cloud systems may stop delivering cloud solutions and shut down services in use. That is a problem. There were several cases. For example, the Sun Cloud, it was one of the first providers of the cloud computing resources, and when the Oracle bought them, they closed the Sun Cloud services. So people who use these services, they would not be able to use their services anymore. Everything that they developed that used these Sun Cloud services, it was ruined. It was a waste of time. So no one can guarantee that these cloud providers would forever and ever provide you the services in the state that is currently available. So you need to be prepared for this. Third, it is impossible to control your own surroundings. You do not know who your virtual machine is sitting next to. In the cloud computing world, you are not the only user of the server. For example, in this server, we have a set of virtual machines, we divide them, and only this part of the server is available for you. And you are the user of this virtual machine. Another virtual machines on this server are used by other users. They are very, very different, and they can use their virtual machines for their own needs. For example, on one of these virtual machines, one of the users can launch some application that would deal with some legal issues in some country. And that would lead that the IP address of this machine at all would be banned in the access from some country. That was the example when in Russia the ministry banned the Telegram, and it is banned still now, Messenger. So the server for the Telegram Messenger can be located on the same server in the same IP subnet as your virtual machine, and you can do nothing with this. And if it would be banned, then your service with the service of all other users would also be banned to the access from, for example, from the country. It was very, very interesting issue because one of the servers that was banned for a long time was the smart light bulbs server for, I think, Philips Corporation that was located on the same subnet where the Telegram servers were located. So users of the smart light systems, they would not be able to use them because their virtual machines were located in the same subnet of the network of the cloud computing provider as the Telegram server. Also, when we are dealing with the cloud computing systems, we are dealing with high security risks. When you transfer your data through open network to the cloud or from the cloud, you need to be ready that your data would be available to all the observers. So you need to use some methods to encrypt your data. So when you process data on remote uncontrolled systems, you should be able to encrypt the process of the data processing, because if you are not encrypting your data, there could be some issues when some third-party member would access your data on the remote server, and that is a huge security risk. So what is the current state of cloud computing? Very brief discussion before we close the lecture and before the last question. So if we would like to see the history of public infrastructure as a service, we can use these Gartner squares that describe the most leading companies, the visionaries, niche players, and challengers in the world of public infrastructure as a service providers. And we can see here that from the 2011, Amazon Web Services was the leader. And from 2011 to 2014, Microsoft went from the visionary to the leader. Also, we can see that in 2016, there was two leaders in the public infrastructure as a service market, Amazon Web Services and Microsoft. And Google tried to go there as fast as possible. 2018, Google is already in the leaders. And right now we see that we can distinguish 6 companies who are big players in this market. Amazon Web Services, it is huge. It is really huge. It provides more than all other cloud computer providers today combined. That is how they are huge. Of course, Microsoft and Google, they think that they can beat them, and they are trying their best to provide the best services, and they're trying to compete on the prices. And for the niche players, Alibaba, it is a very, very big player in the Asian market. Oracle and IBM, they are very big players in the enterprise market sector. So these, if you're trying to understand what public cloud providers are the biggest today, you can go to these guys. Conclusions on the market, it is like Amazon Web Services, it is easy to start. Right now, on our next lecture, we would discuss how to start our very, very simple Amazon Web Services virtual machine. Microsoft has grown significantly, and it provides the Azure and Linux distributions inside the Azure. Right now, Microsoft Azure is one of the biggest players in the market. IBM cannot solve their problems. They constantly change the API, and it is very hard to maintain. And 10 years after the discovery, the market of public infrastructure as a service solutions, it is consolidated right now. So we have big players and we have a lot of small players that are not so big as Amazon, Microsoft, and Google. And users expect the clouds to be reliable, scalable, and better supported. So that is the finish of the introduction to the cloud computing. Today we discussed the origins of cloud computing. We discussed the methods of the service provision in the cloud computing systems. We discussed advantages and disadvantages, and we discussed the top players in the market today. So thank you very much for your attention, and let's go to the final test in the lecture.